Hello and welcome to the eOrganic webinar on planning for flexibility and effective crop rotations presented by Chuck Mohler of Cornell University. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. We are a community of cooperative extension service personnel, researchers, ag professionals, organic certifiers, and practitioners. You will be able to find the recording of this webinar, information about our upcoming webinars, as well as articles, videos, and more by going to our website at www.extension.org/organic_production. I'd like to briefly introduce our speaker. Chuck Mohler is a Senior Research Associate in the Department of Crop and Soil Sciences at Cornell University. He has been studying the ecology of weeds and non-chemical methods of weed management since 1983. He has worked on a variety of issues related to organic crop production and currently serves as the project director for a large multidisciplinary project comparing various organic cropping systems. He is co-editor and principal author of Crop Rotation on Organic Farms, a planning manual, published by NRAES in September 2009. After the 45-minute presentation, you will have the chance to ask questions of Chuck. If you have a question, you can type it into the question box on your screen and hit return. If you can't see the question box, click the small plus sign next to the word question on your control panel to open it up. We will answer as many questions as we have time for. Okay, now I'm going to hand things over to Chuck.
Okay, good afternoon. As Al said, I'm going to talk to you about planning for flexibility in crop rotation and trying to make your crop rotations more effective, hopefully. So there are a bunch of definitions of crop rotation. This is the one used by the National Organic Program. And basically the idea, in a nutshell, is that you vary the crops from one year to the next, the crop species that are grown, so that you're not growing the same crop in the same field more than one year at a time. So crop rotation is always a good idea regardless of what kind of farmer you are, but for organic farmers, a good crop rotation is really essential for success. It's really critical for managing disease organisms, particularly soil-borne diseases, and it's also very important for managing nutrients effectively, controlling weeds, building soil quality, and it even can be useful for controlling some insect pests, though not many of those. Now, from the outset, I want to make it clear that rotation can't solve all problems. It's not a panacea. Some disease organisms are well controlled by crop rotation. Tomato bacterial spot is one example. If you don't have tomatoes for 1 to 3 years, it will get rid of the tomato bacterial spot. As long as you don't reintroduce it on tomato seeds, you'll be all right. You won't have it there. And I'm not going to go through this whole list, but other diseases, for example, late blight, cannot be controlled by crop rotation because the spores are wind-blown and they blow in from long distances, and it doesn't matter whether you've grown potatoes or other potato family crops in the field for quite a while, they can still blow in. A few insects can be controlled by crop rotation. The corn rootworm, various corn rootworm species, it can be, as long as you don't grow corn after corn or corn after winter squash or pumpkins, I should say any kind of squash or pumpkins, you're probably not going to have a problem with corn rootworm. Most other insects, however, have some stage at which they're flying around and they can disperse into your field regardless of whether you've rotated the crops or not. So I think crop rotation has the potential for being really very complicated, particularly on diversified organic farms. Here in the Northeast where I work, typical number of crops on an organic farm will range somewhere from 8, 6 or 8, something like that on a grain farm, maybe even as many as 10 or more on a grain farm. And diversified organic vegetable farms often have 30 or more different crop species that they're growing in a given year. And there's huge variation in the acreage of each of those crops, and consequently, you just can't say, well, I'm going to grow cilantro after my tomatoes because, you don't grow typically nearly the acreage of cilantro that you would of tomatoes. Some crops are in the ground for more than 1 year or have some kind of peculiar timing of their planting. Garlic's planted in the fall and harvested the next summer, and that's going to constrain, what crops can follow what crops. Some crops are planted multiple times during the year. Here we grow, many vegetable growers will grow lettuce, 6, 7 different crops of lettuce, and obviously a spring planted lettuce, the crops that can follow that are going to be different than a fall planted lettuce. Or a summer planted lettuce. And some crops can only be grown in certain particular fields depending on what kind of soil types you have. Some farms may vary quite a bit in their soils, and certain crops may only grow well on certain fields and so forth. And then finally, cover crops have to be intertwined in between the cash crops, and that adds a level of complexity. And this shows the sort of situation you see commonly on diversified vegetable farms. Up here at the top, we have a cover crop. I believe that's oats and peas. And then a more recent planting of lettuce, a couple of different varieties, and then some onions, and a later earlier planted lettuce. And you can imagine, the next year you're coming in and you're wondering, well, where was the lettuce exactly? We don't want to put lettuce where we had lettuce, but you need some kind of planning framework to keep all that straight. Now, the Northeast Organic Network was a group of growers, farming organizations, and researchers got together back in the early part of the 2000s, and we had a big three-year collaborative project, and one of the things we tackled was this problems of crop rotation and how to improve crop rotation planning. And the way we started was by getting a group of very experienced farmers together and asking them how they planned crop rotations. And the reason we took this approach was if we'd approached the question experimentally, I don't think we would have gotten very far. We could have maybe had 5 treatments or 10 treatments at the outside maybe, and different crop rotations that we'd study, and we could do that over a course of 3 years. It would have to be a pretty short rotation because we only had funding for 3 years, and I don't know that we would have learned all that much. So what we did was we got these farmers together and we asked them in a very formal way, a very intensive way, how they planned crop rotations. And the process was that we got these farmers together for a 3-day workshop, and we ran this process on them. The abbreviation is DACUM, and it stands for Develop a Curriculum. And it was originally devised for developing training manuals for industry. So, if you want to know how telephone linemen, if you want to teach telephone linemen how to put lines back up on telephones after a storm's blown them down, it doesn't make much sense to ask the guy who sits in the office, the boss, how to do it, because he may not have ever actually gotten up on the pole. So you get a bunch of linemen together, and you run this process on them and get the information. Well, the New England Small Farm Institute was one of the collaborators in the NEON project, and and they had pioneered using this DACUM process to put together training information for training, training materials for new farmers and other sorts of uses with farm audiences. And so here are the farmers. Actually, this is only 11 of them. Jim Garrettson, a potato farmer in Maine, had to go back a little early before we could get this picture. But anyway, I'm not going to go through all the names. I will point out a few that I will mention during the course of the talk. This is Drew Norman down here, big wholesale vegetable producer in Maryland. Jean-Paul Cortens, I'll mention him later in the talk. Talk about some of the things he's doing on his farm. And he's got a big 1,000-member CSA in the Hudson Valley. This is Paul Arnold. We're in Paul Arnold's living room here. He hosted, he and his wife hosted, Sandy hosted this event. All these are amazing farmers. I wish I could tell you all about them, but we don't have time for all that. So the way the DACUM process works is you identify a series of quote, duties, large processes that, in this case, a farmer would do to plan crop rotations, and then a series of tasks within them. And so this shows an example of duty would be gathering data. This is one of the things the farmers identified as something they do as part of their crop rotation planning process. And then one of the tasks that they do within the category of gathering data is to walk fields regularly to observe crop growth and field conditions. And so here we are putting this together. Here are the duties in green down this side, and then the various tasks across stuck up on the Arnold's wall. And this is Tina Overtomb. She was a trained DACUM facilitator, run many of these DACUM processes. Rick Tonsmeyer from the Small Farm Institute was assisting her. And here are the farmers all gathered around in a circle, and here I am back in the corner just taking notes. I wasn't allowed to talk during this, which I thought was interesting and probably advisable, not to let me butt in, but just to listen. It was very interesting listening. The problem, of course, is the farmers just did a lot of that intuitively, and you know, Tina had to really work to kind of extract the process, the steps that they went through. So these are the duties they identified. Start by identifying the goals of the rotation, you know, what you want to accomplish. Then the resources and constraints that the farm is operating under, gather data, and in particular categorizing crops into different groups by planting date and so forth, family, that sort of thing. Field characteristics, you know, the different soil types and aspects and things. And then they analyze the data. They actually put the plan together, that is, place crops onto fields in some sort of sequence. Then they execute the rotation, that is, grow the crops. That's what it boiled down to. And then evaluate the rotation, how well it was executed, and make adjustments to the plans, plan for next year. And here's the big chart they produced, and it's much too detail here, too much detail here to go into at this point, or just to show you what they came up with. The bottom line was that none of the 12 farmers developed long-term rotation plans. The forward planning horizons typically 12 to 18 months. They have a crop mix, that is, an amount of each species that they intend to grow for the coming year. They look at each field, or in the case of small-scale intensive vegetable growers, each bed even. They look at the conditions of that field or bed and the history of what crops were grown there, and then they place the most appropriate crop on that spot. And the way in which they choose that most appropriate crop is all kind of built into that chart I just showed you. And I'll kind of extract some key nuggets from that in a little bit. They usually have a plan for the next cover crop, sometimes for the following crop, but they don't plan. None of them planned further in advance than that. And the reason was that they had all found that long-term plans always got derailed. You know, they'd have weather problems that would delay planting, and that necessitated planting a different crop than the one that they planned. The market conditions would change, and they wouldn't be, they'd lose a market, or a market would be reduced for a certain crop, but they find a market for a different crop, and then they need to find some place to grow that. The labor supply, it might change. Maybe they plan to grow something that required a lot of labor to harvest or to hand cultivate, and then they discover they don't have the labor and they have to change the plans. So the plans always got derailed, and consequently they found that it just wasn't worthwhile to make long-term plans. So where does that leave us? Well, one thing was very interesting, that although all of them did this sort of ad hoc placement of crops onto particular fields or beds, some of them did that within a larger framework, a larger scheme, you might say. Drew Norman, for example, who I pointed out a little bit ago, he would have 2, maybe 3 years in vegetables, and then he'd rotate that field into hay. And he'd have it in hay for a couple of years and then back into vegetables. Well, that, you know, which vegetable crop he grew in any particular year and at a particular spot was based on this sort of ad hoc placement. But the fact that he was out of vegetables for a couple or 3 years at a time on each field meant that everything became much simpler. You know, it was much less likely that he would follow a crop too soon with a crop in another family. He had that opportunity with the hay crop to build up soil quality, build up nitrogen in the soil, and so forth. Other farmers that Neon studied, I should say that we, in addition to the crop rotation initiative, we also had, we're doing case studies on a number of farms. And some of them used a sort of a large rotation scheme within which they did their ad hoc placement. Eric and Ann Nordell, a farm in in northern Pennsylvania, they have basically a 4-year rotation plan. They grow cover crops and then have a tilled fallow usually during the summer, and then plant a fall cover crop that winter kills, something like oats and peas like I showed in that picture a while ago. And then the following year they'll plant spring planted vegetables into that winter killed cover crop. They'll till it up a little bit and plant some spring vegetables like onions. And then they'll plant a cover crop after that. The following year, the cover crop will grow. Then they'll till it under, have another fallow period to flush weeds out of the soil, reduce their seed bank in the soil, and then plant a fall planted cover crop. And then the following year, they'll till that cover crop under to supply nitrogen and organic matter for a summer planted vegetable crop. And they'll just keep going around and around. Well, which vegetables are planted in any particular year is you know, kind of arbitrary. They'll just decide that on the fly, but they use this sequence. Now, they actually have their farm organized into 12 half-acre strips, and that sequence of 4 crop types is repeated 3 times across the farm. And this slide shows a picture of 3 of the strips. So here we have oats and peas. Those will fall kill, winter kill, and next year those will go into spring planted vegetable. Here we have the summer planted vegetable, and vegetables, carrots in the middle, with rows of rye interseeded into the carrots, and then you know, fall brassica crops on either side there. And then off to the left here is I think rye and hairy vetch planted, that'll go planted. So what happens? This strip goes into spring planted vegetables next year. The rye here next spring will be allowed to grow and then tilled under in the summer. This strip will be fallow, and then it will get planted probably to oats and peas for the next year spring planted crops. And then over here, this strip will the rye and hairy vetch will be tilled under in the spring, and summer planted crops like these carrots and summer planted brassicas would be planted in there. Now, probably it won't actually be carrots and summer planted, you know, who knows, maybe it'll be tomatoes and squash or something. But and in any case, these strips march across the field. And because of these fallow periods in between, these fallow periods and cover crop years, they it just simplifies their crop their ad hoc placement of crops, makes it much easier. For example, their onions are one of their big money makers, and since they always plant the onions in the spring, they're absolutely guaranteed of never having an onion crop more than once in every 4 years on a particular strip. Alice, for some reason I'm not advancing, and I don't know why. Okay, here we go. Oh, no, we jumped one. I'm going to try. Okay.
Okay, let me try to get you.
No, we've jumped two. Back up one more.
Okay.
There we go. Okay. So another example of one of these general plans, Klaus and Mary Helm Martin's farm in central New York. They farm about 1,400 acres, grain and some processing vegetables, mostly grain. And they basically follow a 3-year plan for the most part. There'll be a bean crop of some sort, and follow that with a small grain, and then some kind of heavy feeding crop, usually corn. So the bean could be soybean, but it could also be dry beans or even snap beans that they'd sell to a processor. And then the small grain, ideally they like to plant winter grains because there's a little more money in it, winter wheat or spelt, but if they can't get it in on time after the bean crop, because of rain or something, then they might go to barley or oats the following spring. They usually overseed their grain with red clover, and that gets then plowed down the following year to supply nitrogen for a heavy feeding crop like corn or sweet corn or cabbage. Again, which of those crops in any given slot gets planted is going to be done on a kind of ad hoc basis. They'll look at the field and think about it and decide which crop goes where. But by following this kind of general scheme, it just simplifies things. It makes sure you don't grow beans after beans or get stuck in a situation where you have to grow beans after beans or corn after corn in order to grow enough of each crop that you want to grow. And occasionally they'll depart from the sequence. They might have, you know, plant oats and then plant winter wheat after it or something like that. But it tends to fall back into this 3-year scheme. And this shows that there's Klaus on the tractor cultivating his corn, and the following year it would be in soybeans up here, and then it would go to spelt or winter wheat or something like that. This is a crop of spelt, and the green haze you see under there isn't weeds. That's the clover that's been interseeded into it that'll supply nitrogen for the corn crop. So we try to put the information together that we gotten from the farmers, along with a lot of library research, into a manual. It's called Crop Rotation on Organic Farms, a planning manual, and we'll give you some information about how to obtain this. It's got a subsidy from SARE to produce this, so it's a little cheaper than it might have been otherwise. And this just shows what's in the book. There's a short introduction, then a chapter on the DACUM process and what we learned from it, chapter 2 there. Then chapter 3, we rounded up experts on various subjects that worked a lot with organic farmers. So plant pathologists wrote a section on managing diseases using rotation. I wrote a section on weed management, rotation weed management. We have a section on soil health and nutrient management, insect management in that chapter. Then there's a chapter that has a bunch of example crop rotations from, I believe, 16 different farms, and real 4 or 5 year sequences that farmers actually grew in actual fields, and then some discussion of characteristics of those, what's interesting about them. And then there's an attempt to take the DACUM, the information we got from the DACUM procedure, and put it into a step-by-step planning procedure that can help a grower place crops onto fields in a systematic sort of way. The DACUM chart that I showed you basically says kind of conceptually how farmers do it, but it isn't really a step-by-step plan and planning procedure, and so I attempted to put that together in that chapter 5. Then chapter 6 talks about crop rotations during transition from conventional agriculture, and the final chapter is on crop rotation and intercropping. Intercropping can be very useful, but it also can complicate crop rotation planning. And then there are reference tables. About a third of the book is reference tables, and I'll just mention some of those. There's a table of crop characteristics, the family of the crop, but perhaps the most interesting part of that table is there's information on the amount of nitrogen, phosphorus, and potassium that each crop will take up based on 1,000 pounds of yield. And then crop sequence problems and opportunities. I'll say a little more about that in a minute. Sources of inoculum for crop diseases, so whether the disease lives in the soil and can be managed by crop rotation, or whether it blows in from somewhere else, how long you have to keep out of that crop or related crops to get rid of the soil-borne diseases, and so forth. There's a table of weed characteristics relevant to crop rotation, things like how long do the seeds last in the soil, the size of the seed, which is related to competitiveness of the weed, and so forth. Whether it's annual or perennial or biennial, that sort of information. Crop diseases hosted by weeds. It does you no good to rotate away from a particular family of or group of crops if you have weeds there that are hosting the disease you're trying to get rid of or avoid. And so that table lists the diseases of weeds that are not diseases of weeds per se, but the crop diseases that are hosted by weeds. And then finally, there is an appendix that explains how to make field maps with Excel. This was something invented by a fellow who worked for Jean-Paul Cortens, who I pointed out in that slide, and actually is amazingly simple. Anyone who can use Excel, even even in a kind of minimal sort of way, can put one of these maps together using Excel spreadsheets. It's really a very neat procedure, and I'll show you an example of it in a little while. Okay, so this is one little tiny corner of the problems and opportunities table, and across to the left, down the left side here, we have the preceding crop, and actually there are 52 crops, both vegetables and field crops and cover crops actually included in that table. Then across the top we have the following crop, the crop that would be next in the sequence, and then in the various cells, if there's nothing, then we couldn't find any information saying that there was either a problem or an opportunity related to that. But if there is a letter there, then that indicates that there's a problem and an opportunity. And so a problem is indicated by something like a D or an I or a W. If it has a minus after it, that means an opportunity. So we have D for disease issues, I for insects, W for weeds, C for kind of cultural agronomic issues, N for nutrients, and S for soil physical health. So just as an example, well, the X is just, P after P is a no-no for, it's not allowed within the organic standards, so I just put X's there. Make things simple. No point going into the details of all the rotten things that happen if you tried to do that. But let's take a lettuce and then follow it with tomatoes. We see a D here. It turns out that lettuce is a symptomless carrier for tomato anthracnose. So if you have tomato anthracnose in your area and that's a disease that you're worried about, you might want to not grow lettuce before your tomato crop. On the other hand, there is an opportunity with lettuce and tomato in that often tomato being a summer planted crop, you could get a crop of lettuce in before you actually transplant in your tomatoes. So there's an opportunity to that sequence, though there can be disease problems associated with it. And I should say all of those, all the details are in notes associated. Each cell of the table has notes associated with it. Now I'm going to run through some of the highlights of the planting procedure, just to point out some of the considerations of crop rotation that you might want to think about, how to think about it, how to go about planning crop rotation. The purpose is not to tell you what to do. Really, it's rather to help organize information, to make decisions in an orderly series of steps, so you're not going back and having to redo things, and to facilitate checking for problems after you've got things set up. And the goal in putting that procedure together was really to try to set up a system where less experienced growers could plan crop rotations that were as effective as advanced farmers with many years of experience, highly skilled growers. So the first step, as with the first goal, as with the first duty under the DACUM process, is to define what the goals of the rotation are. What do you want to accomplish? And then prioritize those goals. Often avoiding soil-borne disease is a major reason for rotating crops, but you might want to be growing and fixing cover crops to supply nitrogen, suppressing weeds, and so forth may be goals as well. The next thing I think one should consider is whether you want to try to do your crop placement on the fields within the context of some sort of generalized plan. One of these general schemes that I mentioned, the Nordells and the Martins and Drew Norman, those folks use. And to tell which of those you want to do, it depends on how complicated the farm operation is. One of the most critical aspects of this is whether there are rest years in the rotation. Vegetable farms that have years in which there are fallows or cover crops planted or hay crop, it's out of vegetables. That just makes things much simpler and makes one of these generalized schemes much more possible if you have enough land to do that. Other factors that make that more possible is if there are relatively few crops. It's easier for grain growers typically to have a generalized rotation scheme than vegetable growers because they grow fewer crops. Low variation in acreage among crops also makes it easier. If you only grow one cash crop per year, that makes it easier. The Nordells could certainly grow, say grow lettuce before those summer planted fall brassica crops, but they don't. They just grow one cash crop per year, and it makes things much simpler for them. It makes it possible to have this more generalized scheme. And then minor variation in soils. If you can grow anything on any part of the farm, that makes it easier to have some kind of general scheme. And then on the other side, over here, we have the converse of each of these, few crops, many crops, and so forth. And if you're in this situation where, you're multiple cropping, growing a crop every year, have high variation in acreage among crops, and have a lot of variation, so you can only grow certain crops in certain fields and all that, probably better just to focus on getting a good sequence of crops in a given year. That is, making sure that you look at the past 3 years or so of your crops, and then you want to optimally place each crop based on that history, and that's probably the best you're going to be able to do. A generalized scheme may not be possible in a farm that has these sorts of conditions. Important step is to write down the crop mix. How much of each crop do you want to grow? How many acres, or if it's a small-scale farm, how many beds, how many square feet of each crop. And this just shows an example from the book. It's a real simple example because I wanted to illustrate something. But you write down that crop mix. And then once you've got the crop mix, you can check for family return times. And this is a very important thing, particularly for vegetable growers. What you do is this is the acreage of each crop in this column. So we've got the crop, the acreage, and then the family. And you add it all up, and it's a total of 3 acres. So this is a small farm. We see that if we add up the potatoes, the tomatoes, and the peppers, which are all in the nightshade family, 1 acre of that 3 acres is in nightshades. Now, if we divide the 3 acres by the 1 acre in nightshades, we get the number 3, which is the minimum average return time for the nightshade family on this farm. That is, if the farmer allots the families to beds or fields in the optimal fashion, so that there's as much spacing between nightshade crops as possible. On average, a bed is going to have a nightshade crop 1 year out of 3. You just can't do it. That's just the math of it. Actually, that I think any good plant pathologist would tell you that is opposed to disease risk. There are a bunch of different diseases, soil-borne diseases, that are likely to build up and cause problems for nightshade crops if they're planted that frequently. Generally, a rough rule of thumb is to try for return times of at least 4 years as a preventative. Now, if a disease does build up, then you might need to go longer to get rid of it. But as a preventative, 4-year return time is probably about the minimum you want to have for most crop families. Now, the exception there is grasses. You can grow grasses more frequently. Because corn, most of the small grains, and the forage grasses, mostly they do share a few diseases, but mostly they're different between those, and with a little bit of thought and knowledge of what your disease issues are, you can grow those different kinds of grasses in some kind of sequence. You don't have to stay out of grasses for 4 years otherwise, or 3 years. Otherwise, grain farmers would not be in existence. Okay, so another important step in the crop rotation planning process is to make what I call a crop rotation planning map. And what you want are equal area planning units, and you map out the farm. So, you know, in some cases you might have a long skinny field and the planting units are long and skinny. In other places maybe they're wider and fatter. For vegetable farm, these might be actually beds. This shows an example of for a grain farm, and these are, you know, strips, which you often see on grain farms. And the idea is that having the areas equal makes it easier to go from moving crops from one field to another, because you're moving from one group of strips to another group of strips, and it's easier to keep keep track of where things are. And the other thing about having it arranged like this is you can indicate the various characteristics. You know, if there's a wet spot in this strip, you can note that there's a wet spot in that strip and keep track of where it is. You can maybe grow something here on this strip and this strip, but let this dry out, and so forth. Okay, and then corresponding to that map, there's a table in which each management unit has you know, you have notes on the critical characteristics. By critical, I mean the ones that matter for crop rotation. Sure, the characteristic, you know, might be next to down by the creek. Is that a critical characteristic? Well, maybe it is if the deer wander out and eat the soybeans. But maybe not. You know, it just depends on what matters. And then in addition to those critical characteristics, and there probably won't be more than a couple for each field at most, and some fields or management units, I really should say, are you know, may not have any critical characteristics. That is, they're just kind of your average baseline condition for the farm. And then in addition, on the table you want to write down what the crops are for the past 3 years. And this shows an example. So, you know, here's the management unit number 9, and it has a characteristic of being able to plant early crops on it because it maybe has a south slope, or it's sandy and well drained, or something warms up quicker. Excuse me. And then here are the crops that were grown during the last 3 years, and the cover crops that were grown in between. And what you see is that sometimes, you know, adjacent management units may have the same crop, as here with the peas followed by sorghum Sudan grass, but then at other times maybe they're split, and different types of crops are grown on each. And having it all laid out like this, it makes it easy to track and keep track of where you've grown what in past years. I'm going to skip that. Basically, you sort the management units into similar types, and then you want to actually begin to put crops on fields. for next year. You know, write down what the crop's going to be for each unit. And you can either write it on the map directly, or you can write it on the sheet. You're going to want it both on a sheet for records and on a map as well, because you can take a lot more notes on a spreadsheet than you can on a map. And actually, that procedure, I noted, you can kind of coordinate those two together. So you want to do the place crops in a particular sequence, I think. You want to start with the cash crops that are already in the ground. So you're planting for next summer. You're not going to want to plow up plow under a new planting of hay that was just established the previous year, and you're probably not going to want to plow under you know, the garlic that was planted in the fall or whatever. So put those down on your sheet. Then start with families that are close to the minimum allowable return time that I discussed, because those crops need to be well spaced in time, and if they're not, you're going to run into problems. I should say that it's usually the experienced farmers who figured out what their big money makers are that run into rotation problems, because they know that, you know, they can sell lots and lots of heirloom tomatoes or whatever it is, and they end up feeling economic pressure to grow too much of that particular crop. Maybe for grain growers, it might be, you know, tofu soybeans or something. You just make a lot of money on it, so you want to grow a lot of it, but then you run into problems. So then after you've placed those families that are close to the minimum allowable return time, you want to probably do your highest value crops, and especially those that are going to require special field conditions. If there are only certain portions of the farm you can plant those, or that where they do best, you might want to put them down next. Then other valuable crops that can grow anywhere, kind of fill them in, and then finally fill in the less valuable crops. And of course there's some caveats. You don't want to grow crops in the same family too soon, and consult that disease table for that. Look for problems and opportunities of various sorts in placement of crops. Take advantages of management units with special characteristics if you can, but of course you might not be able to. You know, that might get trumped by, because you can't grow the same crop too soon, or you're going to have disease problems. And then finally, it's a good idea to spatially separate early and later plantings of the same or closely related crops. You know, you have your, you don't want to plant your June lettuce right next to your May lettuce, and your July lettuce right next to your June lettuce, because the diseases and the insects just build up from one crop to the next, and after a couple of crops you got a lot of you can sometimes have a lot of problems. And this just shows a real-world example of the sort of process I've been talking about. This is from John Paul Corten's farm, you know, he has his fields laid out in 8 bed chunks with drive lanes in between. This way, you never have to take the vegetables across more than 3 beds to get it to a wagon. And then, you know, each bed has you know, says what crop was grown there this year. Now note here that all these are you know, early peas and then a later planting of peas. So it's all peas, but it's you know, they're a group of beds that are planted the same thing. You know, it's not like there's a bed of peas here and then, you know, in some other field somewhere there's another bed of peas. It's organized. But then, you know, this may have had peas on it last year, but now it's broken up. You know, this strip has, this bed has chard, and this has scallions, and so forth. So just a real-world example of making a planning map, of, like I said, and using it. And this shows a picture of one field on his farm. With here's some beds that haven't been planted and some that I guess still have cover crops or something on them. Not sure what it is on those. And this shows a bed, some carrots, a couple of beds of carrots, and then a bed that hasn't been planted or is just planted. And this shows the table that's associated with that. And he multiple crops, though he also has. He made the comment to me last winter that he's Nardellized his farm. He goes into cover crops and fallow every other year now on most of the land. Actually, he has a 5-year scheme rather than a 4-year scheme. But 2 of those 5 years are cover crops and fallow. But when he is growing things, he often multiple crops. So he's got peas and follows that with a summer lettuce crop, and so forth. This got in there twice somehow. So then, once you've planned for what you're going to do next summer, you want to check your crop mix and make sure that you've actually got on the map the same amount of each crop that you had proposed originally to plant. And then you can begin to plan 2 summers from now. Probably don't want to go further than 2 summers, but one of the reasons to go that far ahead, you may not actually grow those crops, but by planning what you're going to put in 2 summers from now, that allows you to then go back and fill in a logical cover crop to go between the crop next summer and the crop the following summer, because what you want to grow is going to depend both on the preceding crop, what cover crop you're going to want to grow. It's going to depend both on the preceding crop and the following crop. And I've known an awful lot of growers who, well, I've got this out of here. I'm not sure what I'm going to grow next year. I'll plant rye and hairy vetch. I got time to do that, so I'll put that in. And then next spring they decide, oh, well, I want to put it in an early crop, and they plow under all that vetch. And, it's kind of a waste because the vetch seed costs money, and you didn't really get any nitrogen out of it if you plowed in too soon. So anyway, it's just a way of keeping things organized. So once you got the plan, once you know what you want to plant next summer in terms of each bed or each field, you put it on a map and go out and walk those fields. That's one of the things that the DACUM farmers really emphasize. You want to go out and look at the field, look at the map, and kind of plan it. What the expression one of them used was farm the land through in your head. Kind of think about what it's going to be to actually grow that crop on that field and harvest it and bring it to market. One farmer said, well, I don't like to grow my heirloom vegetables too far from the paved road because my heirloom tomatoes too far from the paved road because they bounce across all this, rutted farm lanes and stuff, and then you end up bruising them, and they don't market well. So you think through all those kind of considerations and write down notes, maybe think about how you could change the plan a little bit, move things around, and also think about what could go wrong. Well, this field is down close to the creek, and 1 year in 5 the creek floods up onto it, and if I plant this crop there, am I willing to risk losing the opportunity to grow that crop? What would I do in that situation if that happened? Note down what you do for various contingencies, make some contingency plans. So that's pretty much the story, and in conclusion, I just say that there are lots of ways of using the planning manual we put together. It's pretty useful reference. It's got a lot about basic principles and concepts of crop rotation. You can look up very particular information about diseases, weeds, crops, and whatnot in there. I think it can be pretty inspiring to see what these various highly experienced farmers are doing. Look at their crop rotation sequences and you know what they're following with what, and how they think about crop rotation. And then finally, there is this systematic planning tool that you could use with you know, sheets and maps and whatnot to put together a plan for your farm. So that's it, and I guess I'll turn it over to, oh yeah, here we are. This shows the picture of the crop rotation planning book, and you can get that at the NRA's website, which is shown up there, and I guess it's time for questions.
Okay, thank you very much, Chuck. We have about 20 minutes for questions, and for those of you who missed the beginning of the presentation, you can use the question box on your screen to type in questions and hit return. If the question box is closed, you can click on the small plus sign next to the word question to open it up and then type in your question. We'll be reading the questions out loud, and we'll answer as many as we have time for. This webinar will also be posted on the eOrganic website within the next week in case you'd like to view it again or missed anything or would like to share it with someone else. And that's why the eOrganic website is included on this slide here. If you lose track of that, you can always just Google eOrganic webinars, and that's probably the easiest way to find all of our webinars, many of which are recorded on the site. So now Chuck will answer some questions. I'll just read them in the order that they came in. What crop rotations would you use on a small 1/4 acre market garden? Would you use cover crops in the rotations, and which one? That's a pretty general question.
Yeah, I'll tell you. I'll tell you what I do. I'm not a market gardener, but I have a very large vegetable garden that I grow a lot of our staple foods on. I group the crops into families that work well together, and family groups that have about the same, together the group has about the same area of crop that I want to grow. One group's solanums, one's sweet corn and squash, and then there's an everything else category. And then have a break year of cover crops, and that's the sequence I use. But you know, it's just going to depend on what crops you want to grow. I think having 2 years of cover crops in there would be better. But anyway, that's you know, that's a fairly simple way of doing it on a very small scale operation.
Okay, thank you. Another question, how best to use a crop like sun hemp and trap the nitrogen?
Wow. I know what sun hemp is. I've seen it grown. It doesn't work very well up here in the Northeast. It's but it's a warm season nitrogen fixing legume, and I think you'd probably use it after a spring, you know, early season crop, and then you know, grow it during the summer when it grows well, and then till it under perhaps for a fall season, fall planted crop. That wouldn't work where we are up here in the Northeast. There just isn't enough growing season. But then I think if you're talking about sun hemp, you're probably in the South or maybe California, and you might have enough growing season there to you know, grow a spring crop, and then sun hemp as a nitrogen fixing cover crop, then follow it with a fall planted crop.
Here's another question. Chuck, how well do you think your book translates to the arid Intermountain West for mixed vegetable operations? What parts do and what parts don't?
The basic procedures and whatnot definitely translate completely. The tables of diseases are going to be a little less a lot of the diseases are going to apply regardless of where you are, but some of them are going to be a little different in your area. Most of the weeds are going to be similar, but you're going to have some additional weeds that like kochia and possibly others that we don't have to worry much about here in the Northeast. I think so. I guess what I would say is that crop sequences and whatnot are going to be of interest. The basic procedures, the DACUM process, and what those farmers had to say, all of that's going to be of much interest to you. Some of the specifics in the tables, maybe a little less so.
Okay, next question is, what do you plant for your fallow year?
Well, it depends on what kind of farm you have and what you're what you want to do with that fallow. Like I said, what the Nordells do is they plant a fall cover crop after their vegetables, and then the following year fallow they till that under, have a bare fallow, which the point of that is that they they cultivate that fallow 2 or 3, 4 times, and that flushes weeds out of the seed bank and reduces their weed pressure for subsequent vegetable crops. And actually, it's the most weed-free farm I've ever seen. They just hardly have any weeds, except for a few dandelions that blow in on the wind from neighboring farms and roadsides and so forth. And then after that fallow period, they plant a fall cover crop that then they till in under the following spring before another vegetable crop. So that's one way to do it. Another, some folks would maybe plant a longer cover crop like red clover. If you really are looking for maximum nitrogen, you probably want to leave the cover crop there for the whole year. So maybe you'd have a spring nurse crop of some grain, and then overseed that with red clover, and the red clover grow, and by the following spring, when you tilled it under, you'd have you could easily have 100 to 200 pounds of nitrogen there in that cover crop. So it depends on what you're trying to get. There are different approaches. Another approach is just to grow a sequence of cover crops through the season. That's going to put the maximum amount of organic matter into the soil. So, you might have your fall planted cover crop after your last vegetable, and then till that under and plant sorghum Sudan grass or buckwheat in the summertime, and then plow that till that under, and then plant a fall cover crop, something like that. That would put a lot of organic matter in, a lot of nitrogen in the cover crops if you planted legumes in there as some of the cover crops.
Okay, we had another question about, was there a specific reason for rye between the carrot rows? Would other grasses like oats or barley work for the same purpose?
I think they would. The reason for rye, the reason they chose rye is that it is a very big biomass producer. Rye grows taller than most other cereal grains. A lot of the rye we grow here in the Northeast, the kind of field-run cover crop type rye, is mostly grown for straw for animal bedding, and it's been selected for long straw and high productivity. You grow a dwarf wheat or a semi-dwarf wheat, it's not going to produce as much biomass. A barley would be intermediate. I find oats to be an excellent cover crop for fall planting because it doesn't doesn't go into a reproductive stage. So if you here where we are in central New York, we plant it in early August, and early August is much better than late August for us. And by the time it winter kills, I mean the culms, the stems are literally the size of your finger. They're just amazing and just really lush and all this leaf, and it just produces a massive amount of biomass. So, you know, there are various advantages to different crops. If you plant a grain in late summer, it'll like oats or spring, well, oats in particular, or spring barley, or some other frost-sensitive variety, it's gonna winter kill, and that will be nice for putting in an early vegetable crop because it'll already be, you know, partially decomposed on the ground and easily incorporated. Won't slow you down in the spring. But you know, for other purposes, you might want to use other crops. The reason they're using rye is just because it produces a massive amount of biomass, and since they just are only putting in, you know, one row of barley, one row of rye every about 3.5 feet. I'm sorry, 2.5 feet, 30 inches, I think. 30 inches, 40 inches, somewhere in that range between their rows. They, you know, they want something that'll be very productive and flop over and cover the ground through the winter and so forth.
Okay, we had a question of someone asking for advice about what to do if she wanted to harvest some of the cover crops like clover, oats, and barley to dry for sale as teas before they get tilled in.
Oh, so what's the question? I mean, why not?
Said,
sure, go ahead.
Yeah, it just said, how would you advise me if she wanted to do that?
Well, I don't see any problem with it. You know, the amount you're going to harvest for tea is probably pretty small relative to the amount you're growing. So, yeah, I don't know what what the advice would be. Yeah, you go in and pick some. You know, if you're talking about trying to produce, you know, bales of tea, I suppose, you know, you mechanically harvest it. Certainly a clover would grow back. You know, I frankly don't think there's a whole lot of difference between harvesting clover in the fall versus not harvesting in the fall, and what you get out of that in terms of nitrogen if you're tilling it under in the spring for a summer planted crop. For red clover, I just don't see, you know, the clover dies back largely over the winter. That material goes back into the soil. The crop then, the cover crop, the clover, takes it up again in the spring, and just doesn't fix as much nitrogen as it would otherwise because it's taken the nitrogen up out of the soil. So I think, you know, if you harvested the clover in the fall, I think you'd still get the pretty close to the same nitrogen contribution from the clover when it was plowed under in the spring. As far as grains, grasses, if you were harvesting some of those, certainly winter wheat is often grazed with very little yield loss. Now it would delay how long until you can, and I would think clipping it for tea would be a similar kind of process. You could take some cutting off just after it starts to, you know, after it's tillered good and in the spring, early on, and then but before it started to really do much in the way of elongation, it would still grow in May, and you could incorporate that then and get a pretty good organic matter contribution. I hope that answers the question. It's I never thought really about it particularly, but.
Okay, we had a question about your book and whether it discusses the specifics and timing of each of the cover crops.
The book is not a manual on cover crops. It's a manual on crop rotation, and I think that's a misconception people often get. This is about crop rotation, and it deals with cover crops. It has a lot of information about cover crops, but I think if you're interested in timing of cover crops, the SARE cover crop manual, I think it's called Growing Cover Crops Profitably or something of that effect, is an excellent resource, and I'd recommend you refer to that.
Okay. Yeah, there's a couple of questions about cover crops here from the same person. One is, can you recommend any summer cover crops for arid areas like Texas, especially for dryland farming? Other than sorghum or Sudan, there seems to be few options. And then the same person wanted some recommendations for wet areas like rice fields that won't drown out in the winter and rainy season.
I'm afraid I'm out of my area of expertise here on these two questions. I could make some speculations, but I think there are sources that might be of more help than I could be. I haven't worked with rice, and I haven't. I've been to Texas, but I can't say I know much about cover crops in arid Texas. I apologize.
Okay. Let's see. I'm just trying to see if there are any more questions. Here's one. Do the principles and concepts of crop rotation in this book apply for the tropics as well?
I think the principles and concepts do apply to the tropics as well. Now, the specifics in terms of, information in the tables are not going to, about diseases or particular weeds are obviously not going to be as useful. But the basic concepts and principles, I think, do apply. Yeah, very much. I think they're pretty universal, really. And we try to cover both vegetables and grains and systems which would be mixed vegetables and grains, which a lot of tropical cropping systems are growing both. And I think a lot of the material on intercropping is of interest there, and the trade-offs between crop rotation and intercropping are very applicable to the tropics.
Okay, well, thank you very much. I'd like to thank you all for your questions. And I just want to repeat that the webinar will be posted on the eOrganic website along with the slides at the address on your screen. You can also Google eOrganic webinars and you should be able to find it. And on that website you can also find out about our upcoming webinars. So thank you all, and thank you again, Chuck.
Thank you.